In our quest to understand the universe and our place in it, one question has always stood out: are we alone? The search for extraterrestrial life has led scientists to look beyond our own planet, with Mars, our neighboring planet, being one of the most promising candidates for this search. Scientific consensus suggests that billions of years ago, Mars might have looked very different from how we see it today. It was probably a warmer, wetter place, closer in resemblance to Earth. Mars's geological history indicates that liquid water, an essential ingredient for life as we know it, existed on the planet's surface. Rivers might have carved their paths through the Martian soil, lakes might have nestled between its hills, and rainfall might have dampened its sands. This era, known as the Noachian period, ended about 3.7 billion years ago, was probably the most habitable period in Mars's history. In our ongoing search for signs of past life on Mars, one element has garnered much attention: water. On Earth, wherever we find water, we find life. That's why astrobiologists often live by the motto, follow the water. And follow the water we did, all the way to Mars. In the past 2 decades, spacecraft orbiting Mars have discovered signs of both liquid water and water ice. But perhaps the most intriguing evidence comes from recurring slope lineae, dark streaks that appear during warm seasons, grow, and then fade as it gets colder. Some scientists suggest that these streaks could be caused by salty liquid water. Our knowledge about Mars's past and present has been largely shaped by robotic missions. Notably, NASA's Mars rovers have been key players in our exploration of the Red Planet. The Mars Science Laboratory mission's Curiosity rover, which landed on Mars in 2012, found evidence of an ancient Martian environment that could have supported microbial life. It discovered that Gale Crater had once held a lake and that this environment had the necessary ingredients for life: water, chemical building blocks, and a stable climate. More recently, in February 2021, NASA's Mars 2020 mission successfully landed the Perseverance rover on Mars. Perseverance's mission is to seek signs of ancient life and collect samples of rock and regolith that might be returned to Earth by future missions. It's an ongoing and exciting endeavor, and the world awaits with bated breath as every piece of data potentially brings us one step closer to answering the question of past life on Mars. Among the promising signs of life we're looking for on Mars, the presence of methane stands out. On Earth, much of the methane in our atmosphere is produced by biological processes. Thus, when methane was detected in the Martian atmosphere, it sparked interest and debate among scientists. Could this be a sign of life? Or is it the result of geological processes, such as the interaction of rock and water? As we delve into Mars's past for signs of ancient life, some are also looking to its future. Elon Musk, the CEO of SpaceX, has a vision of making life multiplanetary. His ambitious plans involve establishing a self-sustaining colony on Mars within this century. It's a vision that, if realized, would undoubtedly alter our perception of life in the universe and significantly advance our understanding of our potential in space. However, colonizing Mars is no small task and comes with a plethora of scientific, logistical, and ethical challenges. On the scientific front, potential Martian life, if it exists at all, is most likely to be microbial. Microbes are known for their resilience and ability to thrive in extreme conditions, including environments on Earth that closely resemble the harsh conditions of Mars. Scientists search for biosignatures, signs of past or present life in the geological records of Mars. They hope that rovers, like Perseverance, can find definitive biosignatures in the Martian soil, like the shapes and patterns that Earth microbes often leave in rocks. Astrobiology, the interdisciplinary scientific field concerned with the origins, early evolution, distribution, and future of life in the universe, has a significant stake in our Martian explorations. Astrobiologists seek to understand the potential for life to arise and survive on other planets and how humans might detect it. Mars presents an ideal case study in this regard. The discovery of even microscopic life on Mars would have profound implications for astrobiology, dramatically increasing the estimated probability of life existing elsewhere in the universe. However, even if we find evidence that Mars once hosted life, the question remains, could Mars support life today? The Martian surface is harsh, with freezing temperatures, thin atmosphere, and intense radiation. But below the surface, conditions might be more favorable. There, shielded from harmful radiation, liquid water could exist, and with it, perhaps, life. However, when considering the potential for life on Mars, it's important to distinguish between habitability, the potential to support life, and inhabitation, the actual presence of life. Mars is a great example of a potentially habitable world. It has the necessary ingredients for life, including water, chemical elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, and it might have a suitable environment for life underground. But whether Mars is inhabited or was inhabited is yet to be confirmed. Conversely, some scientists are considering whether Earth organisms could survive on Mars. This concept, known as forward contamination, is taken very seriously in space exploration. NASA's Office of Planetary Protection ensures that we take steps to avoid introducing Earth life to Mars, which could complicate the search for Martian life and potentially harm a native Mars ecosystem if one exists. The search for life on Mars is a multidisciplinary effort involving fields from astrobiology to geology to chemistry. It's a search that has the potential to answer fundamental questions about life itself. What is life? How does it begin? Are we alone in the universe? Regardless of whether we find life on Mars, the search itself will undoubtedly advance our understanding of life and the universe. It's a journey well worth taking, for Mars and beyond. In considering these potentialities, the idea of transforming Mars to make it more Earth-like, a process known as terraforming, has also been proposed. This could involve melting Mars's polar ice caps to thicken the atmosphere and increase the temperature, eventually creating conditions where liquid water is stable on the surface. However, such an undertaking would be an enormous, centuries-long endeavor far beyond our current technological capabilities. As we contemplate these visions of the future, we continue to study Mars with a multitude of scientific instruments. Satellites orbit the planet, rovers trundle across its surface, and stationary landers monitor the environment. Each mission returns data that helps us piece together the Martian puzzle and brings us a step closer to understanding whether life ever arose on Mars. With each new discovery, Mars continues to surprise us. Scientists have recently uncovered complex organic molecules, the chemical building blocks of life, in 3-billion-year-old rocks on Mars. Elsewhere, radar data suggests the existence of a subglacial lake beneath Mars's southern polar cap. If confirmed, these bodies of liquid water could provide a refuge for life as we know it. Simultaneously, the study of extremophiles here on Earth, microorganisms that thrive in extreme environments, has expanded our understanding of what constitutes a habitable environment. Some extremophiles can tolerate conditions similar to those on Mars today, surviving in cold, dry, and radiation-heavy environments. Their existence suggests that if life ever did arise on Mars, some hardy microbes might still persist. While the technological challenges of sending humans to Mars and establishing a permanent presence are immense, the potential scientific returns are equally substantial. In-depth geological studies of Mars could provide insights into the planet's history and its potential for harboring life, both past and present. If humans do reach Mars in our lifetime, they could conduct experiments and studies far beyond the capabilities of any rover, opening a new era in our understanding of Mars and our universe. The search for life on Mars is far from over. Despite the many challenges and uncertainties, the prospects are exciting. Every new finding provides a fresh perspective and a piece of the puzzle. While we are yet to find definitive proof of life on Mars, the journey of discovery itself is enlightening. It enriches our understanding of the universe, our place in it, and perhaps most importantly, the extraordinary phenomenon we call life. In this ambitious quest, we stand on the precipice of potential discovery that could redefine our understanding of life as we know it. Mars, our neighboring planet, has been and continues to be a beacon for our curiosity, driving us to ask profound questions and seek answers beyond our terrestrial confines. Whether or not we find life there, our investigations of Mars will undoubtedly continue to expand the frontiers of our knowledge, unraveling the mysteries of the red planet and, in turn, shedding light on the intricacies of our own world.